Hello my dear students, and welcome to our lecture on the polar coordinates and the cardioid. You actually might be familiar with polar coordinates from your previous studies in pre-calculus, especially trigonometry. But that said, I'd like to start from the very beginning with polar coordinates. Okay, so for this topic, we will discuss the following: polar coordinates, Cartesian coordinates, graphing functions in polar form, finding derivatives in polar form. And how do we convert from polar coordinates to Cartesian coordinates? How do we graph a function that's given in polar coordinates, etc.? And uh, at the end of the lecture, we'll turn into a calculus topic, which is finding derivatives in polar coordinates. So, what are polar coordinates? Remember the Cartesian coordinates x and y, where x is the distance along the x-axis and y is the distance along the y-axis? Well, you can describe the location of a point in a plane a different way using polar coordinates. Okay, so here's how it goes. Imagine you have a point xy sitting on the plane somewhere. Okay, well, we define the r value to be the distance from P to the point of origin. And then we define theta to be the angle the line joining the origin and point P makes with the positive x-axis. So this is angle theta. So we have two coordinates, r and theta. So those are the polar coordinates of the point P with the Cartesian coordinates xy. And so r is the distance, and theta is an angle. Okay? So let's compute, let's practice computing with some polar coordinates for some Cartesian coordinates in the plane. Now, suppose your xy is the point 0, 2. Okay? So, where is it? The x value is 0 and the y value is 2. So, it's up here along the y-axis. Okay? So, what's the r value? How far is this point from the origin? Okay, how far is this point from the origin? This distance? Right, 2 units from the origin. Okay, and the angle it makes with respect to the positive axis. What angle does it make with the positive x-axis? Right, it's 90 degrees or pi over 2. Okay, so the distance from the origin to the point 0, 2 is 2, and the angle formed between that segment joining point P and the origin is with the positive x-axis is pi over 2. Okay, so the coordinates would be 2, 2, and pi over 2. Now, how about, let's look at another point. Okay, so this is how it goes. So, the coordinate is, okay, 2 pi over 2. Now, let's look at another example. How about, okay, -1, -1 in the Cartesian coordinates. Okay, xy is -1, -1. Well, first of all, where is that point located? -1, -1, where is it? -1, -1 is in the third quadrant. And how far away from the point of origin is it? How far is it from the point of origin? Okay, this one is 1 unit. This is 1 unit. And so how far is this point from the point of origin? Then the distance would be given by the Pythagorean theorem. R must be equal to the square root of 2. So that's our R value. So our R value here is the square root of 2. The question is, what kind of angle does it make with the positive x-axis? So let's see. So well, the angle goes along the angle goes all the way around the 5 pi over 4. Okay, so 5 pi over 4, there it is. Okay, so the polar coordinates of the point -1, -1 then are, okay, the square root of 2 and 5 pi over 4. Okay, so now I said that r was the distance from the point to the origin, but tell you r can be negative, and sometimes they call that the directed distance. So it's very common to have negative r values, and sometimes they call that the directed distance. So let me show you what I mean. Now let's go back to the first example, 0, 2. Okay, so 0, 2 were the x and y coordinates, and we discovered that r theta was 2. So it's 2 units away from the origin. And the angle was pi over 2. This angle was pi over 2. So 2, r is equal to 2. And theta is equal to pi over 2. Okay, so well, I could describe that point a different way. I could describe it as go down to the angle minus pi over 2. Okay, so go down. So it will be minus 2 units. And the angle would be, okay, this is a negative angle generated from in a clockwise manner. So it would be negative pi over 2. So r now is a negative number, negative 2. And the angle is also negative pi over 2. Or you could do it another way. You could do it as go around 3 pi over 2. And then go a distance, a directed distance. So negative 2, and generate this angle in this manner. This is equal to 3 pi over 2. And this one works. Okay? So, not only can you use negative r values, but you have seen that we can have multiple angles ending at the same point. Of course, you can, because every time you go around 2 pi, you're back to where you started from. Okay? So, the lesson is, the polar coordinate of a point are definitely not unique. Hindi lang nag-iisa. So, Cartesian coordinates are unique, but not their polar form. Okay? So, now we constructed the polar coordinates of some points using our knowledge of geometry and trigonometry. Then we plotted those points and see where it is located. But there are formulas for converting from one coordinate system to another. And here are the formulas. So I want you to analyze the picture. So if you have a point xy, and I'll put it in the first quadrant to simplify things, and its polar coordinates of r theta, well, then you can immediately see that cosine of theta would be x over r. So, x is r cosine theta. And then, y would then be given by r sine theta. From sine theta equals opposite y over r. So y is r sine theta, opposite over hypotenuse. So now if you're given the polar coordinates of a point r and theta, you can immediately compute or transform it into its xy coordinates by using these equations. Okay, and then you can go backwards. Okay, next, what is tangent theta in the picture? Okay, tangent theta. Okay, so it's y over opposite over adjacent, y over x. And what about r squared? Okay, what about r squared? Well, r squared would be x squared, okay, plus y squared. In other words, r is the square root of x squared plus y squared by the Pythagorean theorem. But I want you to allow for negative r values. So a better equation is r squared equals x squared plus y squared. So that set of equations, these set of equations would permit us to convert from Cartesian over polar. Okay? But you'll see in a minute that it's more difficult to go that way. Okay, so let's have more practice. Okay, let's go from polar to rectangular. Okay, now suppose you're given the polar coordinate square root of 3 pi over 6. Then you ask yourselves right away, where is that point? Okay, where is this point? Okay, yes, it's in the first quadrant. Is a distance, its distance rather is a square root of 3 from the origin. And it makes an angle of pi over 6 with the positive x-axis. Okay, the next question is, what is the r coordinate or is the x coordinate and the y coordinate? Okay, so what's the x coordinate? Okay, remember from a while ago, x is equal to r cosine theta. So let's use that equation. X is equal to r cosine theta. So it's the square root of 3, okay, cosine of pi over 6. So our r is square root of 3 and theta is pi over 6. So we plug in values into the formula. Okay, so square root of 3 cosine pi over 6. And now we have a pre-calculus trigonometry. Okay, we have to know what cosine pi over 6 is. And that turns out to be square root of 3 over 2. Okay, so square root of 3 over 2. So your x value would be square root of 3 times square root of 3 over 2 is 3 halves. How about sine? Okay, what about sine? Or what about y rather? Okay, what about the y value? Okay, y value is given by the formula r sine theta. Okay, so it's r square root of 3 sine pi over 2. So it's square root of 3 times 1 half. Okay, so sine of pi over 6 is 1 half. So the final answer would be 3, a square root of 3 over 2. And so, my Cartesian coordinates are 3 halves, okay, and square root of 3 over 2. Okay? Now, let's go the other way. Let's take a point, okay, -1, negative square root of 3. Okay? So this one is a Cartesian coordinate and we try to find its polar coordinates. Take note, they won't be unique. Okay, so let's do it. So this one is a little tougher. First of all, r squared is the x coordinate squared plus the y coordinate squared. R squared, okay, equal to x squared plus y squared. So it would be negative squared. It would be r squared equal to -1 squared plus Okay? Sorry, let's put it here. Okay, r squared is equal to negative 1 squared plus negative square root of 3 squared. And when simplified, this is equal to square root of 4, because 1 plus 3 is 4, and square root of 4 is 2. So r is 2. R can be 2. So r is equal to 2. Okay? Or you could take r to be negative 2. Okay? Remember, it's distance from the origin. So it could be positive, it could be negative. So r could be positive 2, r could be negative 2. But for the moment, let's use r equal to 2 muna. So let's use r is equal to positive 2. So the point is 2 units away from the origin. Okay, 2 units away from the origin. 2 units, 1, 2. So 2 units away from the origin. But you ask yourself, in what quadrant are we located here? Okay? In what quadrant are we located here? Yes, we're in the third quadrant kasi both x and y are negative. So that's going to mean something when we calculate the angle. So how do we find the angle? Well, we all know that tangent theta is y over x. Okay? And that's a conversion formula, which is negative. Do we have it here? Okay, the negative square root of 3 over negative 1, which is equal to the square root of 3. Okay? So the minus sign cancels. Okay, so this is now trigonometry in action. Now, which angles have their tangents equal to the square root of 3? Okay? Now, I want tangent of some angle to be the square root of 3. Okay, what are these angles? Pi over, yes, theta is pi over 3 and 4 pi over 3. So, for instance, okay, we have the fact that the tangent equals square root of 3. Now, which angle would I pick? Okay, which angle would I pick? Well, I am the third quadrant. So, I'd better go all the way around to 4 pi over 3. Okay, so one set of polar coordinates is 2, 4 pi over 3. Okay, so it will be 2, 4 pi over 3. That's one set of polar coordinates. Okay, that is if you selected pi over 3. But what about if you selected pi over 3? You'll be in the first quadrant. And then you'd have to go a distance of negative 2. Okay, so 1, 2. Okay, so that's another set of polar coordinates. That would give us negative 2 pi over 3. Okay, so negative 2 pi over 3. So it's tough going, I admit, because polar coordinates are not unique. Converting from polar coordinates to Cartesian coordinates is pretty simple. But the other way, from Cartesian to polar, as we just did, that can be a lot harder. You have to worry about tangents of certain angles and the r value being plus or minus. But fortunately, calculators can do all of this. So you can check your answers by looking at a calculator, by using your calculator. Now a quick study tip here is, I suggest that when you're dealing with coordinate systems like this, that you label what system is under discussion. So if you write 1, comma, pi just by itself as ordered pair, it's not clear whether it's Cartesian or polar coordinates. Okay, not clear. So I suggest that you label. Okay, r is 1 and theta is, or the angle is pi. So tell the the students which coordinate system you are using. Now we proceed to some graphing functions in the polar coordinate system. Okay, so what does r equal to 2 look like? Okay, suppose I say r is equal to 2. What's the graph look like? Well, that means the distance to the origin is 2 units. Okay? So what's the graph look like? Well, it's a circle. Okay? The distance from the origin is 2 units, so it's a circle. And in fact, if you square both sides, okay, if you square both sides, you get x squared plus y squared equals r squared, or 4. Okay, remember r is x squared plus y squared, okay, is equal to, okay, 4 when you square both sides here. Okay, so that r squared is equal to 4, but you know that r is computed by, okay, x squared plus y squared is equal to 4. Okay? So it's a circle. And the polar coordinates are really good for describing circles with centers at the origin. How about if I say theta is pi over 3? Okay, theta is pi over 3. What's the curve look like? Well, the tangent theta would be tangent of pi over 3. And that's the square root of 3. Okay? But remember, tangent theta is y over x on the conversion formula, y over x. And that means that y is equal to, okay, by cross multiplication, y is equal to square root of 3 times x. Okay? Square root of 3 times x. Okay, and you know that this one is a straight line whose slope is the square root of 3. The slope is the square root of 3. Okay? So, the lesson here is that if you have a polar function such that r is a constant, okay, positive constant so to speak, it's going to be a circle. Okay? And if theta is a constant like pi over 3, pi over 2, then the graph will be a line. Okay? So those are pretty easy to graph. Let's step it a notch and graph a wonderful curve, one that will remind you of Valentine's Day. And here it goes. The function is 2 times the quantity 1 minus cosine theta. Okay, 2 times the quantity 1 minus cosine theta. And ask yourself, how in the world could I graph that? Of course, you could go to your calculator and graph it. Go to polar mode, and but suppose you had to do it by hand or do it manually. Okay? So how will you do it? Well, you have to do point plotting. Okay? You would pick several values of theta, or various theta values I should say, and compute the sine or the cosine and construct the r value corresponding to that theta value. And you could have a table of values just like this. So for example, when theta, okay, is 0, okay, when theta is 0, what would r be? R would be, okay, 0. It's at the origin, sorry. Next, the distance r is equal to 0. And when we say theta is pi over 3, okay, when theta is pi over 3, that's cosine pi over 3 is positive 1. Okay? So 1 minus 1. Okay? 2 times 1 minus 1. I'm sorry, when theta is pi over 3, I should say. Okay, when theta is pi over 3, that's 1 half. So 1 minus 1 half, 2 times 1 half, correct? And 2 times 1 half is equal to 1. Okay, when theta is pi over 2, 2 times the quantity 1 minus cosine of pi over 2 is 0. Okay, and 2 times 1 is 2, and so on. Okay, so this is like doing our xy table of values, but just this time theta and r. Okay, so we completed the value for theta and r. And then you could keep generating these values, and then we connect them with a curve. Okay, so the first point would be 0, 0, the point of origin, this 0, 0. And then pi over 3 and 1. Pi over 3 is 60 degrees, so somewhere here. And 1, so the distance is 1 though. So this is the point. Then pi over 2 is 90 degrees, so it's here along the positive y-axis, and 2, so 1, 2, so another. Okay, point 1, sorry, this is 1 unit, 2 units, so the point is here. And then you have 3 pi over 3, 3. Okay, so 1 unit, 2 units, 3 units, and this one is 2 pi over 3. Okay, and the rest, the next rather is pi over 4. Pi and 4 rather. 1 unit, 2 units, 3 units, 4 units. Okay, and this one is pi, correct? So this is the other point. Then you have 3 pi over 2. This is where 3 pi over 2 is, and 2 units. Okay, 3 pi over 2. So this is 1, 1. Why it's 2 units? Here, 3 pi over 2. 3 pi over 2 is 270. That's exactly along the negative y-axis. And 2 units, 1, 2. So it's here, this point. Okay? So this is the point. And then we can now connect. And then this one is for 5 pi over 3. Okay? So this is for 5 pi over 3. Then we connect the points to determine the curve. Okay? So, the curve generated, look at the curve generated. This is what we call the cardioid. Okay? So, as you can see, it kind of looks like a heart. So, it's a heart-shaped curve. Okay? So, the lesson is plotting polar points can be slow going. Kasi if you have to do point plotting. Okay, that said, our technology would allow us to do quickly, graphing quickly nowadays. Okay, so now let's turn to some calculus. Okay, so let's calculate some derivatives. So let's use the same cardioid. Let's use this cardioid where r is equal to 2 times the quantity 1 minus cosine theta. Now, if you look at the picture, do you see any places where there might be horizontal tangents? Okay, looking at the graph, I can see a couple of places. And what about vertical tangents? How many do you see here? Okay, there are some vertical tangents too. And then perhaps very interesting, what's happening at the origin? Okay, it's not clear at all. Okay, so I'd like to talk about how to calculate derivatives in particular. Okay, so finding the horizontal and vertical tangents. So here we go. You're given a function like r equals f of theta, like the previous cardioid. Okay, that's a polar graph. Okay, well, the way to calculate the derivative is just to go back to our knowledge of parametric equations. Okay, so remember, okay, x is r cosine theta by the conversion formula. Okay, x is equal to r cosine theta, and y is equal to r sine theta. So it's f of theta, okay, f of theta cosine theta, and y is, okay, f of theta sine theta. So I have x and y in the parametric form. Okay, where theta is the parameter. Okay, so I have the parametric equation for x and y. Well, I know how to calculate derivatives with parametric equations. It's easy. All you just have to do is say dy dx, okay, or dy d theta divided by dx d theta, and then we calculate dy d theta. Okay, so it's a bit complicated because it's a product rule. It's the derivative of, okay, so it's the derivative of f theta sine theta, and that derivative of course is f of theta times cosine. Okay, first times the derivative of the second, diba? The first times the derivative of the second plus the second, which is sine theta, times derivative of f, which would be f prime of theta. And in a similar fashion, you get the denominator as derivative of x with respect to theta. And you have this formula for dy dx. Okay? So when you do have a horizontal tangent, that's when the denominator dy d theta equals 0. And the denominator doesn't equal 0. And you have vertical tangents when the denominator is 0, and of course the numerator is not 0. If they're both 0, then we have some interesting conclusions to make. Okay, so this is derivative of y with respect to theta. Okay, so the first times derivative of sine is cosine plus the, okay, second sine theta times derivative of the first. All over, the denominator is derivative of x with respect to theta. So it's okay, the first times derivative of cosine is negative sine theta plus the second times derivative of the first, it's f prime of theta. Okay? So when do we have a horizontal tangent? When derivative with respect to theta of y is 0, and vertical tangent if dx with respect to theta is 0. Okay, so alright. So, quick study tip before we do our example. Okay? If you're trying to find the derivative of a polar curve, okay, write it as x equals r cosine theta and replace r with the function under consideration and then work with that. And the same with the y value. Okay, do the same with the y value. So let's do a quick example. Okay, so an straightforward example which will illustrate these ideas of vertical and horizontal tangents. So let's look at the polar curve r equals sine theta. Okay, so I'll put theta between 0 to pi. Okay, so there's your polar equation. So what's how would this curve look like? You can do point plotting here, or you can use your calculator and wait a few minutes. Okay, so let's look at the graph. I tell you this will be a nice looking curve. R equals sine theta. Okay. But now let's do the derivatives. Okay, so let's do the derivatives. So if R is sine theta, and we know what R is, okay, it's sine theta. Okay, R is sine theta. So it's sine theta cosine theta. R is sine theta cosine theta. So X is sine theta cosine theta. What about Y? You know what R is? It's sine theta. So sine theta, which is sine squared theta. So these are the parametric equations for my polar curve. Y equals or X equals sine theta cosine theta, and Y equals sine squared. Okay? Now, where are the vertical tangents? Okay, and when the denominator is 0, okay, dx d theta, derivative of x with respect to theta. So let's differentiate sine theta cosine theta. Okay, and when you do that, what will we get? So let's differentiate. Nauna si d theta. Meron ba siyang dx? Wala si dx niya. So let's first differentiate sine theta cosine theta. When we differentiate dx with respect to theta, what will this be? The first is sine theta. Derivative of the second is negative sine theta. Okay, plus the second, cosine theta, times derivative of the first is cosine theta. So it will be cosine squared theta minus sine squared theta. Okay? So cosine squared theta minus sine squared theta. So it's minus sine squared plus cosine squared, or cosine squared minus sine squared. And you know very well that there is a trigonometric identity to that, which gives cosine to theta. Okay? So, I did not write here, but let me reflect. Dx d theta is equal to, okay, the first derivative of x with respect to theta is, the first is sine theta, okay, negative sine theta, negative, plus, or I'll use the red ink na lang, magnify so I have a place to write, so I could write it properly. Dx, derivative of x with respect to theta is equal to the first sine theta times derivative of cosine theta is negative sine theta, plus the second is cosine theta times derivative of sine is cosine theta, which when simplified is equal to negative sine squared theta plus cosine squared theta, which is equal to cosine 2 theta. Okay? So it's cosine 2 theta. Now, I want this to be 0. So if we solve cosine 2 theta and make it equal to 0. Let's see. Okay. Let me add one more. How do I add a page? I forgot. Okay, there it is. Okay, so cosine 2 theta equals 0. Okay, so what angle, yan, cosine cosine 2 theta is equal to 0. Sorry, 0. Then 2 theta must be equal to pi over 2, which means that theta must be pi over 4. Okay? So, when theta was pi over 4, or, okay, where else is cosine 2 theta 0? Also at, where else is it 0? At 3 pi over 2. Okay? Okay, so 2 theta is also equal to, when 2 theta is equal to 3 pi over 2. And when you multiply both sides by 2 or by 1/2, then theta must be equal to 3 pi over 4. Okay, 3 pi over 4. So, when theta is pi over 4 or 3 pi over 4, we discover that there is a tangent. Let's see. Vertical tangent, sorry, horizontal tangent. Vertical tangents rather, at theta equal to pi over 4 and 3 pi over 4. So, let's look at the graph. Okay, so where are pi over 4 and 3 pi over 4? Pi over 4 and 3 pi over 4. Okay, so if we draw this, okay, imaginary line here, that one, and this two. Okay, these are the vertical tangents of the function. Okay, so in yellow, yan. So, the vertical tangents of the function are at theta equal to pi over 4 and theta equal to 3 pi over 4. So, this is the picture of the curve under consideration. Okay? R equals sine theta. Then, you can do the graph by point plotting, but notice some of the outcomes here. So, when theta is pi over 4 and 3 pi over 4, we discover that there is a vertical tangent. Okay? So, this one is a circle. Okay? This is a circle. And those are the vertical tangents. These are the vertical tangents to the circle. And at 0, Then at 0 and pi over 2, yan, at 0 and pi over 2, these are the horizontal tangents. So, from dy naman tayo. So, let me add one page so I could present the... How do I add another page? Okay, so one more page. It's from this time, what was that? dy over d theta. dy over d theta is sine theta or sine squared. So when we differentiate, okay, let me use this color. Derivative of y with respect to theta, and y is equal to sine squared theta. Okay, what will this be? Derivative would be, sorry, not sine squared, but sine 2 theta, sine squared I should say. It's sine squared theta. Okay, what will this be? It's 2 sine theta, okay, cosine theta. Okay, 2 sine theta, cosine theta, 2 sine theta, and cosine theta. If we go back, okay, yan, 2 sine theta, cosine theta is actually sine 2 theta. Okay, from our trigonometry, okay, so this is equal to, okay, sine 2 theta, okay, sine 2 theta. Okay, then we equate this to 0. Sine 2 theta is equal to 0. Okay, and which function values will give a sine value of 0? Okay, which values? Okay, let's take 2 theta is equal to, when is sine 0? At 0 and at, okay, there are two values here, and at pi, diba? At 0 and at pi. But, okay, from 2 theta is equal to 0, okay, that gives theta equal to 0. Theta is equal to 0. And if 2 theta is equal to pi, then theta must be equal to pi over 2. Okay? So, at 0 and at pi over 2, at 0, sorry. Okay, so at 0 and at pi over 2, we had our horizontal tangents. Okay? Horizontal tangents at 0 and pi over 2. So, let's go back to the graph. Check the graph of the, okay, polar function. Okay, at 0, look. Okay, at 0 and at pi over 2, can you see these lines? That is a horizontal tangent. This one too is a horizontal tangent. Okay? So, now you might say, oh, is that really a circle? How do you prove that this one is a circle? How do you prove that this one is a circle? Well, you can manipulate, okay, the equation and get into a Cartesian coordinate. And then truly, it will look like a circle. So, let's do the computation. Okay, you start with r equals sine theta. Okay, r equals sine theta. And we want to convert this into Cartesian coordinate xy. So, I want to get rid of the r and get rid of the theta. So, what I'm going to do is, if you multiply both sides by r, then things will be simplified. Because r squared, okay, or r sine theta rather, r sine theta is y. And that r squared is x squared plus y squared. Okay? And r squared is, okay, r squared is x squared, okay? X squared plus y squared. Okay? R and theta have disappeared. Wala na si theta and then r. Okay? And I have here now x squared plus y squared equals y. Well, what's this? Okay, it doesn't look like anything you're familiar with, but we can complete the square. Okay, so it's x squared plus y squared minus y. Okay, minus y. Then moving to the other side, moving the y to the other side rather. Then what do I add there to make it a perfect square? Okay, 1/4. Okay, then add 1/4 on the right to make sure that we don't change the problem. And then this factor to x squared plus y minus 1/2 squared equals 1/2 squared. Okay, so it's yeah, this factored into y minus 1/2 squared. Then so it takes the form x squared plus y squared equal to r squared. So it's a circle. Yes? So it's a circle with the center is at 0, 1/2. Okay, the center is at 0, 1/2. Look at the graph. And the radius is 1/2. Okay? R is 1/2. So exactly the picture that we had before. Okay? So that's a pretty nice example of a circle, because we had a circle and we had the horizontal tangents and some vertical tangents. Okay? So that's it.